All right, it's just after 11. We might get started now. Hi, everyone. Thanks for being here. My name is Mallory, and I am a Community Advisor with Emergency Management Southland. We had initially planned this presentation as an introduction to MetService, what their capabilities are, how they forecast weather, severe weather warnings, that sort of thing. But with the current drought situation here in Southland and the classification we now have of a medium scale adverse event, we thought this would be a good opportunity to not only have that introduction, but also have a chance to talk about how we got into the situation and what the forecast is looking like for the next few weeks. You might have noticed that your cameras and microphones have been disabled. This is to avoid any disruptions. But if you have any questions throughout the presentation, please feel free to put them in the chat. I would now like to welcome Jake Cope, who is a consultant meteorologist with MetService. He will be taking us through everything weather, and I will pass you over to him.
Thank you, Mallory. Good morning, everyone, and thank you for dialing in. As pointed out, I'm a consultant meteorologist for MetService. Before we jump in, though, I do have a couple of quick acknowledgements. So this presentation was put together with no small amount of help from the MetService Manager of Severe Weather Services, Elka Lowe, and with my manager as well, the Manager of Consulting Australia and New Zealand, Georgina Griffiths. So thank you to both of them. And today, I'm going to talk to you first off, a very quick overview of MetService, where we are, what we do, where we get our mandate to do the work we do from, and what responsibilities that gives us. I'll touch very briefly on what goes into a weather forecast, how we make them, and then we'll go on to our severe weather watches and warnings. At that point, we'll take a brief pause. I'll take any questions you've got on that subject before we move on to the second section, which we'll be talking about the dry conditions across Southland. And again, we'll have questions after that as well. So on to MetService then. So we are pretty old. We've been around since the early 1860s. 1992 is probably when we formed in our current guise as a state-owned enterprise. In terms of a national weather service, we're probably fairly small, about 250 staff. 60 of those are meteorologists in one form or another, and they cover 25 shifts a day. So that will cover everything, all the different ranges of forecasts that we do cover, and I'll touch on that shortly. The main headquarters was in Kelburn on top of the hill down in Wellington. I'm in Auckland. They briefly relocated down to Featherston Street whilst the building in Kelburn is upgraded for earthquake preparedness, I believe. That leads quite into nicely why we do have an Auckland office, because if anything should happen to one office or another, we still have a responsibility to get out the safety critical forecasts, so things like forecasting for the airports and aircraft that are in the air. We can't just stop if something hampers one of the offices, so we've got the office split for resilience mainly. We also have MetOcean. They're based in Raglan. Their main focus is on all things marine and marine weather. And in Paraparaumu, we have the technical guys, so the team that maintains and installs, observation equipment and things. And then we've got a small media presence in Christchurch as well. In terms of what a National Meteorological Service does, it's mandated through the WMO, which is the World Meteorological Organization, and also through any particular country's own government, in this case, the New Zealand government. And through the WMO, we are part of a big data sharing scheme, and it provides us with all sorts of access to different networks there. And then in the local legislation, that provides a framework for our mandate and our responsibilities. So as a National Meteorological Service, we provide public forecasts, which includes severe weather warnings. We're actually a lead agency for severe weather, and that feeds into the watches and warnings section of the talk coming up shortly. We do marine forecasts and warnings, both coastal and high seas. Whilst we're not the biggest Met service in the world, we do hold responsibility for about 15% of the world's oceans for those high seas forecasts. Through the WMO, we also represent New Zealand there, and we are the backup for Fiji's Tropical Cyclone Centre, which has been busy over the last couple of days with Tropical Cyclone Feely. So there's a regional specialised meteorological centre there, and we provide backup for that. And we're also responsible for any tropical cyclones that come south of 25 south from that Fijian area of responsibility, which Tropical Cyclone Feely just did this morning. So we're keeping all very busy at MetService at the moment. On top of all that, we also hold the Volcanic Ash Advisory Centre. So when any volcanoes go off and put ash up into the atmosphere, we are a key player in determining the safety of aircraft around those ash plumes. So plenty going on, both at home and abroad. And up on the screen, there's just 3 parts of the New Zealand legislation that give us the mandate to perform that work. And the work that we perform is producing weather forecasts is the long and short of it. To go into that, you see the stool in the top right corner. It's got 3 legs. It's got observing, it's got modelling, and it's got forecasting. So it's very important that the observations are good. And the picture you can see on the left there is one of our weather radars. So that will look out for rain, snow, hail. And we've got several of those across the country. But the observations can be anything. They can be automatic weather stations. We've got over 200 of those. It can be the weather radar. It can be satellites. We have access to international satellites through our membership of the World Meteorological Organization. We have radiosondes, which is basically temperatures and humidity sensors tied to a big balloon and released off into the atmosphere, and that measures various things through the whole depth of the atmosphere. We have a lightning detection system, so if lightning strikes go off, they get triangulated by different stations across the planet, and they point out where the lightning is. We can even see if that lightning is cloud-to-cloud lightning or cloud-to-ground lightning, so that's quite a complex system. Most aircraft that fly, they have temperature and humidity sensors in the nose, and so they submit observations as well. We have drifting buoys, we have ship observations. I guess the point I'm making is we've got lots of things to measure the weather, and the more you can measure the weather, the better you can feed data into the start of those computer models. So those computer models, they're run all over the world. Different forecasting centers have different computer models. There's global models which cover the whole planet, but at a much coarser resolution. And in-house at MetService, we run several weather research and forecasting models which cover a much smaller area, but to a much higher resolution. So all those models work together to produce, they produce output, they produce guidance. It's numerical weather prediction. It's not quite a forecast yet. Quite a lot of the time, they're pretty good. And these days, the weather models do a lot of the heavy lifting in forecasting the weather. But it still comes down to those skilled meteorologists to do the expert analysis, interpret that data, and basically analyze the performance of the models, assess where they're going well, assess where they're going badly, and change them if need be, basically. Once all that information has been collected, that then gets pushed forward and turned into the various forecasts, the warnings that you see, and these can be everything from scripts for television, for radio. It can be the forecast you see on metservice.com. It could be the things you see in the watches and warnings, the whole raft of forecasts. On this chart, you see the solid lines. That's the sort of main line of human produced forecasts. So the observations into the computer models through to the forecasters and then out to the forecast. There are some instances where some observations go straight onto the website. So if you can just see towards the left of the picture of the website there's the current extremes, and that will just be automatically fed in. Those dotted lines are just straight in without a human seeing. And there are some instances as well, usually in the longer range forecast, where the models are deemed sort of good enough that they can go without any human interference as well. So most of what you see will be touched by human hands, some of it is not. The warnings, though, always heavily forecaster driven. They will be based off various parts of model guidance, but it's always down to expert and lead meteorologists to assess the situation. It's quite a collaborative process. It's collaborative with like in-house at MetService. Quite a lot of meteorologists chip in and pass their expertise on their various sections. So the marine people, the aviation people will chip in and contribute to a effective warning system. But as well as that, we work with partnerships outside MetService, so with NEMA, with FENS, with the New Zealand Defence Force, police, various mayor's office, council, civil defence. It's generally a very collaborative process when these warnings go out, and especially when we get up to those red warnings. This is a relatively new system for MetService. We introduced this in May 2019, and the first red warning was in February 2020, which is the one you can see in the bottom right of the screen there. And that was for heavy rain on the west coast, which produced quite significant flooding down there. And even though this color-coded system with the yellow, orange, red is relatively new for us. It's not relatively new for New Zealand. If you look at the fire risk chart in the middle, we've been used to looking at color-coded warnings for a long time, but the difference here is that we start when it's high. So you see the fire risk gets yellow in the middle. That's the first point we go into this. So we're not talking about the usual day-to-day weather here when we start issuing watches and warnings, and especially red warnings. This is the serious business of weather forecasting where there is a risk to property and potentially to life as well. In terms of when we would issue a watch or a warning and why, the criteria on the left-hand side there, you'll see that 3 of those mention an area of at least 1,000 kilometers square, which sounds like a big area, but I've drawn it on the map there, and it's not. It's about 32 kilometers by 32 kilometers. Will give you that much area. So it's not a huge area we're talking about, but it's also not insignificant, about half the size of Stewart Island. So in order for a warning to be justified, you need to meet those criteria across an area of that size or bigger. So it's not just one gust reaching 100 kilometers an hour. It's got to be a significant area, and we'll start assessing the threats up to 6 days out in advance on the severe weather outlook, which is the chart you can see on the bottom right corner. Now that chart is on metservice.com. That's updated twice daily by some of our senior meteorologists, and that will assess the potential for risk up to 5 and 6 days out. It's a useful tool to look at to see if there's anything severe coming your way. And then as we get closer to the event and the confidence builds in the event occurring, or we can narrow down the area where it will occur in, then the team will start looking into issuing watches and warnings. So watches usually will come out earlier than a warning because of the increased uncertainty. You don't want to warn too early and end up with a boy who cried wolf type situation. So we tend to go, if all things go well, progressing through a yellow watch through to an orange warning. And then if the situation is definite enough and severe enough, then a red warning. Now, these are pretty rare. We've only had a handful of red warnings since we started this in 2019, I think 6 or 7 off the top of my head. So not a huge amount of those have been issued. You will notice that thunderstorms run slightly differently. That's because thunderstorms are a whole different beast when it comes to weather forecasting. They develop very rapidly. They're quite unpredictable in where they would develop. And they also die out very rapidly as well. So what we can do is issue a thunderstorm watch because we are very capable of identifying areas where thunderstorms have the potential to develop. The classic analogy for this is if you think about putting a pan of water on the stove, you're pretty certain you're going to get some bubbles in that pan, but you couldn't say where the first one's going to come. That's basically how thunderstorms look from above, where we look from satellites and radars, and they're very tricky to pick. So you tend to get a thunderstorm watch with a little bit of lead time, 12 to 36 hours, not as long as you'd get for a watch or a warning. And then as the thunderstorms develop and potentially become severe, and that's through their rainfall rates, the size of the hail, or the gusts or tornadoes that they're producing, then you would get a thunderstorm warning. And a thunderstorm warning is always a red warning. There's no orange thunderstorm warning. Those thunderstorm warnings will be for specific cells, so one particular thunderstorm as it runs through. And the life cycle of most of these thunderstorms, especially in New Zealand, is just around an hour. So they don't last very long at all. And that means that thunderstorm warnings are very, very tailored, very specific, and they're also very short lead time and they're very short duration as well. So that's the progression. We start with the severe weather outlook. We run through likely into a watch, and then if it's deemed significant enough, move up to a warning, be it orange or red, and then through the event, and then warnings are either extended or let to expire as necessary once the event's ongoing. In terms of where you can find our warnings, all over the place. When severe weather is expected, we want you to know about it, so we're not shy about talking about it. One of the very good ways we've got of getting severe weather information out there is through CAP, this Common Alerting Protocol, which is an XML piece of software which basically allows us to use the same format as various other warnings. There's multiple agencies across New Zealand using this system, issuing warnings for various different things. You can see the situational awareness map there on the Civil Defence Southern website. From the particular busy day, back, when was that? From that the Canterbury red warning, which I don't think it was too long ago. So you can see multiple different warnings go onto the same page, and this CAP system allows us to do that, and it integrates very easily across different things. So it goes into the civil defence maps, it goes into the Red Cross app, whichever method of finding the warnings you've got, it's usually come through there, and it's because it uses the same format everywhere that can be done. But also we push a lot of these things ourselves. So we're on Twitter in two forms. We've got just the standard @MetService, which is everything weather, something interesting, beautiful cloud pictures, just a general weather account. But on there, we will also mention severe weather that's coming up. We also have MetService Warn, which is all business. You won't find cloud pictures on there. That is an automated tweet whenever a watch or warning has been issued, and that will just pop up just with the watch and the warning. You find more detail on the other one, but you get it quicker on MetService Warn. We have the app, which is pretty ubiquitous. It's quite a good one. We also have MetService TV. So there's my friend Angus there talking you through that red warning. We're on Facebook. We usually find quite a lot more colour around any severe weather events on there. And there's good old metservice.com. And at metservice.com, you can also sign up to receive watches and warnings via email straight to your inbox. So there's plenty of different ways that you can get hold of these watches and warnings. And as I say, we're not shy about putting it out there. A nice little feature we have as well is that we have these watches and warnings banners integrated across all our platforms. So you see on the app there, you've got the severe weather information Mount Cook popped up. On the app, you see those banners if there's a watch or a warning in your area. And on the web pages, you see different pages turning on and off. So the warnings page will pop up and become more prevalent on the website when there is a warning in force. So it's all combined to basically make these significant weather events as visible as possible to ensure the safety of New Zealanders. So that is my very brief rundown of MetService and into our watches and warnings. I'll quite happily answer any questions that you guys have put in the chat just about now.
No questions so far. Does anyone have anything?
I've got Rob asking what processes I use to include lessons from past events. It's an ever-evolving beast, is meteorology really. What you find is from past events, you find local knowledge kicks up incredibly. You find that you sort of learn how different weather systems behave as they go across different mountains and through different valley gorges and things. But also there's an element in some of the higher resolution modeling of machine learning. So it basically ingests past events. And what a lot of the ensemble forecasts will do as well, they run on they run on what's basically not the actual climate. They run on what's called the model climate, and that model climate updates every 2 weeks to include things that have happened and things that are likely to happen in, say, for example, a warming environment. So yeah, it's always basically a learning process, whether that be a human learning process for, for example, if you have a missed event, if we miss 130 km/h wind event or something, seems unlikely, but if we did, that would be, there would be in-house processes to work out why that was a missed event. There would also be, we've also got a team of really clever people doing like model development and constantly changing like parameters in the models and developing those. So it's one of those things where you're never going to get any forecast perfect, but you can always try to make it better. Nikki, do you map accuracy by region? I'm not sure what you mean there. If you could elaborate. As in, do we keep a record of the forecast accuracy by various regions? like say, for example, the percentage error for Southland compared to the percentage error for Northland. Not that I'm aware of. A lot of assessing like how a model is performing, for example, isn't necessarily to do with the weather that people experience. A lot of it's to do with the things that drive that weather. So we would look quite a lot at the height of various pressure fields, which is high up in the atmosphere, basically where the jet stream is controlling various parts of the weather. And then we'd also look at how models were performing in terms of the central pressure of a low. So the current example, Tropical Cyclone Feely, just south of New Caledonia at the moment, we'll have expert meteorologists looking at that and trying to assess, which models are performing better there at this exact time. We do have a process, and it goes through quite a long meeting every morning, which we call map discussion, where we select the WRF of the day. And the WRF of the day is one of our in-house models, and we've got 6 of them. And basically, it will be assessed for like the best accuracy usually for the most impactful weather. So if you've got a weather event that's particularly impactful for, say, the West Coast, that would take priority in assessing that model's performance rather than a sunny day in Gisborne or whatever. So yeah, it's I don't think we've got records of previous accuracy by region, but it's definitely a good question. Rob, the presence in Christchurch. I actually haven't been. I don't know. I just know we have a couple of people there. I think it's to do with our I think it's our Weatherscape team, which is our sort of on-air TV graphics, but I'm not entirely sure. I'd have to get back to you on that.